Welcome back to Arxflix. Today, we're diving into an intriguing paper titled Training Language Models to Follow Instructions with Human Feedback. This research tackles the challenge of making language models, specifically GPT-3, more aligned with user intent by utilizing human feedback. Here's a visual representation of human evaluations comparing Instruct with GPT-3. As you see, even the 1.3 billion parameter Instruct model outperforms the colossal 175 billion GPT-3. But how did the researchers achieve this? Let's break it down. Traditional large language models like GPT-3 are powerful, but they often generate untruthful, biased, or simply irrelevant outputs. This misalignment from user instructions is due to the difference between predicting the next token in a dataset and generating useful, safe responses. The researchers approached this problem by fine-tuning GPT-3 using human feedback through a method called reinforcement learning from human feedback, or RLHF. First, they collected a dataset of human-written demonstrations and fine-tuned GPT-3 using supervised learning. Next, they gathered human-labeled comparisons of model outputs to train a reward model. Finally, they used this reward model as a guide to fine-tune GPT-3 using the proximal policy optimization algorithm, creating what they call Instruct. On the research test set, 1.3 billion parameter Instruct outperformed the 175 billion parameter GPT-3, despite having 100 times fewer parameters. The Instruct models produced more appropriate outputs, adhered more closely to explicit constraints, and hallucinated less compared to GPT-3. Instruct models showed significant improvements in truthfulness. On the Truthfulca benchmark, they generated truthful answers about twice as often as GPT-3. Although Instruct models also reduced toxic outputs by about 25%, they did not significantly reduce bias. Despite improvements, Instruct models still make trivial mistakes. They can fail to follow instructions accurately, make up facts, or produce verbose and hedging responses to simple questions. Public NLP datasets like FLAN and TZO were outperformed by Instruct, indicating that these datasets are not fully representative of real-world use cases. Interestingly, Instruct shows promising generalization to tasks outside its fine-tuning distribution, such as following instructions in different languages and coding tasks. While not perfect, the results suggest that fine-tuning large language models using human feedback can significantly improve their alignment with human intent. The paper highlights that using human feedback for fine-tuning language models can align them more closely with user instructions, making them more helpful, truthful, and less toxic. This method shows potential, but there's still room for improvement, especially in reducing bias and handling instructions with false premises. Thanks for watching. If you enjoyed this summary, make sure to like and subscribe for more insights into cutting-edge research in deep learning. See you next time on Arxflix. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.